Vijnana Bharati is a national organization and a movement promoting Swadeshi science and technology across Bharat. It has 22 branches in different states and 4 other contacts in other states. Uh, it works in different areas of Swadeshi sciences and technology like organic farming, uh, then architecture, that is Vastu Shastra, environment, uh, meditation, Ayurveda, astronomy, forestry, and many other such areas. And it has been working in different areas, 11 different areas through different independent organizations and projects across the country. You can get more details about them at their website vijnanabharati.org. For this Vedic mathematics introductory course, RSS IT Milans have joined hands with Vijnana Bharati. IT Milans are weekly RSS Shakha of working professionals, mainly in the IT industry and many other professions. It has 110 branches across Bangalore, and also there are branches in other areas like Hyderabad, Mysore, Mangaluru, then Delhi, Pune, and Mumbai and all. The IT Millers generally meet on every Sunday morning in the form of a RSS Shaka. IT Millers take up annual social welfare drives, uh, and this Vedic mathematics course is one such drive. Let me talk a little bit about Vedic mathematics because so many people are raising questions about why do we need Vedic mathematics and all that. So it's good to have a little bit background about that. India has produced many mathematicians whose discoveries have benefited the world. We all know that sometimes in a funny way people say that India contributed zero to the world. One such mathematician was Swami Bharata Krishna Tirtha, who was living between 1884 and 1960. He was a Jagadguru of Puri Shankaracharya Pita. So obviously he was a student of the Vedas. So he stumbled upon a few sutras and sub-sutras which were quoted in the Vedas. So after extensive research on these sutras, he reconstructed them using which numerical calculations can be done in a simpler and faster ways. And this is what he called as Vedic mathematics. Although he published several volumes on Vedic mathematics, many of them got lost. Don't know how, because there are different theories on that. Lot of it even got hidden and it was not publicized much till early 1970s, and then during that time some British scientists came across and they took it to London and they started studying about it, and that's how it started becoming publicized in a wider scale. In Vedic mathematics, unlike the conventional methods, there are many ways to solve a problem, many ways to arrive at a solution for a problem. This gives us the liberty and flexibility to choose the technique most convenient for us. So you can look at the patterns in the problem and you can apply the most suitable way to solve it. Although you have multiple ways to solve it, there is a fastest way to solve it for that particular pattern. So you can choose that and arrive at the solution. That's the beauty of Vedic mathematics based on patterns. So it can be understood easily by people of any caliber. It enhances the ability to approach and solve any mathematical problem. That's why Vedic mathematics is a blessing to everybody in this day and age when people's numerical skills are deteriorating as the use of calculators and computers is increasingly coming up at a very young age. Vedic mathematics has a shorter, quicker, and easy way to remember techniques. So it enables any student to do calculations faster than they could with the conventional methods. Students of Vedic mathematics will easily overcome their fear of mathematics and gain a newfound confidence to work on any mathematical problem without apprehension. So this Vedic mathematics course aims to promote the traditional knowledge of mathematics mastered by the mathematicians of ancient India. Although this is a very introductory course, the idea here is to trigger an interest so that people can go and explore further into it. So, what are the main benefits of Vedic mathematics? It eradicates the fear of mathematics and instills confidence. It improves calculation speed and numerical skills. It sharpens the brains. It is an aid to crack scholarship and entrance exams. So, like we call it as human computers. It helps in us may becoming human computers. It facilitates a habit of analytical thinking and measured approach towards any problem. It provides an insight into ancient Indian mathematics. It's very useful for everyone, students, professionals, teachers, parents, young and old, all kind of people. Bhaskaracharya, or many people call him as Bhaskara II, is regarded as one of the greatest Hindu mathematicians of all time, and his contribution to mathematics is not just Indian, it is also to the world mathematics. Bhaskaracharya was born in 1114 in Bidur, which is believed to be the current day Vijapura of Karnataka, and he died around 1185, most probably in Ujjain. He was a leading mathematician of the 12th century. He wrote the first work with full and systematic use of the decimal number system. So he was a linear successor of the noted Indian mathematician Brahmagupta as the head of an astronomical observatory at Ujjain, the leading mathematical center of ancient India. Bhaskara's work on calculus predates Newton and Leibniz by half a millennium. He is particularly known in the discovery of the principles of differential calculus and its application to astronomical problems and computations. While Newton and Leibniz have been credited with differential and integral calculus, There is strong evidence to suggest that Bhaskara was a pioneer in some of the principles of differential calculus. He was perhaps the first to conceive the differential coefficient and differential calculus. In his mathematical works, particularly Leelavati, which means the beautiful, and Bijaganita, he not only used the decimal system but also compiled problems from Brahmagupta and others. He filled many of the gaps in Brahmagupta's work, especially in obtaining a general solution to the Pell equation, that is x square equal to 1 plus p y square, and in giving many particular solutions. Bhaskaracharya anticipated the modern convention of signs: minus by minus makes plus, minus by minus plus makes minus, and he was the first to gain some understanding of the meaning of division by zero. He specifically stated that the value of 3 by 0 is an infinite quantity. Bhaskaracharya used letters to represent unknown quantities such as in modern algebra, and solved indeterminate equations of first and second degrees. He reduced quadratic equations to a single type and solved them, and investigated regular polygons up to those having 384 sides, thus obtaining a good approximate of the value of pi equals 3.14166. His other works are Siddhanta Shiromani and Karana Kutuhala. He wrote on his astronomical observations of planetary positions, conjunctions, eclipses, cosmography, geography, and mathematical techniques and astronomical equipment used in these studies. Bhaskaracharya was also a noted astrologer, and tradition has it that he named his first work Leelavati after his daughter. Some of Bhaskara's contributions to mathematics include the following: proof of the Pythagorean theorem by calculating the same area in two different ways and then cancelling out terms to get a square plus b square equal to c square. In Leelavati, solution of quadratic, cubic, and quartic indeterminate equations are explained. Solutions of indeterminate quadratic equations, integer solutions of linear and quadratic indeterminate equations. A cyclic Chakrawala method for solving indeterminate equations of the form ax square plus bx plus c equal to y. The first general method for finding the solutions of the problem x square minus ny square equal to 1 was given by Bhaskara too. Now it's called Pell's equation. Solutions of Diophantine equations of the second order, such as 61 x square plus 1 equal to y square. This very equation was posed as a problem in 1657 by the French mathematician Pierre de Fermat, but its solution was unknown in Europe until the time of Euler in the 18th century. So he solved quadratic equations with more than one unknown and found negative and irrational solutions. He gave preliminary concept of mathematical analysis, preliminary concept of infinitesimal calculus, along with notable contributions towards integral calculus. He conceived differential calculus after discovering the derivative and differential coefficient. He Stated Rolle's theorem, a special case of one of the most important theorems in analysis, the mean value theorem. Traces of the general mean value theorem are also found in his works. He calculated the derivatives of trigonometric functions and formulae. In Siddhanta Shiromani, Bhaskaracharya developed spherical trigonometry along with a number of other trigonometric results.